Hello, so in this video we're going to look at Unit 1, Introduction to Trigonometry. This unit, Unit 1, does cover from 5.1 to 5.4 in the Openstax textbook, first edition, and the link will be in the description below along with the notes. So let's jump into some notes. So first we look at the unit circle, where typically I've recommended students to memorize the top rightmost quadrant, because typically if you can memorize the positions where they're at, you can also get where they're also were on the other quadrants where they're at, if that makes sense. So for example, if we look at pi over 6 at the 30 degrees, we can see that we have square root 3 over 2 comma 1/2. And if we memorize those patterns, we know that at the 60 it's going to be flipped. At the 150 degrees, it's very close, just with the negative on negative square root 3 over 2. So you can think of the coordinate plane. So you know that it's positive, positive, negative, positive, negative, negative, and positive, negative. And if you can memorize where the positions are when you go to do exams, if you don't have the actual liable, you're able to get those points where you need them, or the points that you need. Rather than, if you are able to do repetition and put down a blank unit circle and be able to fill it all in, kudos to you. That's just something that I've recommended to students, to just memorize the top right. And if you can memorize that, then you can get to the point where you need. So next we look at the trig functions, and the trig functions we'll use throughout Precalculus, and you'll use sometimes in calculus. With the trig functions, you can memorize it as SOHCAHTOA, and so we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we know we can see that sine is going to be our y, cosine is going to be our x, and tangent is y over x. And so when you look at the unit circle, your y value will be your sine. So if you have sine of, let's say, pi over 6, and then if you look at the y value for pi over 6, that will be your exact value. And so that's kind of the idea with the trig functions and the unit circles that are able to use, and you can use them pretty frequently. And also, if you were to plug in these into your calculator, and let's say your calculator, like most, don't have the other trig functions, you can always put them in your calculator like this, and you will get a very exact. Next, we have where the trig functions are positive, negative, depending on where quadrant they're in. So you can see that in the quadrant 1, we have all positives. In quadrant 2, only the sine functions are positive. We can see that in quadrant 3, that only tangent is positive. And in the quadrant 4, we can see that only cosine is positive. We are going to have to maneuver from radians to degrees and degrees to radians. And we can typically just multiply whatever our given value is, multiply it by the inverse. So when we use, let's say if we have something in radians, so we have pi over 1. If we wanted to get in degrees, our units will cancel, so that our ending unit is degrees. And similarly, we can have something in degrees, and we can multiply it by pi over 180 degrees. Our units will cancel, and we're left with a value in radians. So next we have the right triangles, and they're pretty straightforward. However, that being said, your A and your B will always be legs, your legs, and your C will always be your hypotenuse. So if you look at the Pythagorean theorem, where you have a squared plus b squared equaling c squared, your A and the B will always be legs, and your C will always be the hypotenuse. Depending on where our theta lies will give us where our opposite and adjacent will be. Next, we have the special triangles, where we have a 45, 45, 90 degree triangle, and we have a 30, 60, 90 triangle. And if you can memorize the positions where they're at, so for example, if you can memorize for a 45, you know that the hypotenuse is going to be square root 2, and your legs will always be 1. If you have a 30, 60, 90, if you can remember that a 30 degrees will be 1, a 60 degrees will be square root 3, and the 90 degrees will always be 2. Whenever you have to use like a reference, so if you have something like this, whatever your angle is in the blue, then that will be whatever angle or special triangle you will have to use. Sometimes it's a 45, sometimes it's a 30, and sometimes it's a 60. It just depends on where it lies. So let's look at some examples, and we'll go over some topics that we recently looked at. So you're more than welcome to pause and try them by yourself or work through the problems with me. So first we want to look at sketching the angles that we're given. So we can see that we're given 135 degrees, and we know that we're going to be 0 and 360 degrees. We're going to be 90, 180 degrees, and 270 degrees. So our 135 will lie somewhere over here. So our angle will be right there. For negative 120 degrees, we know that if we have our unit circle, we have a triangle. If we go this way, we will be positive angle. Similarly, so if we go down, we will be a negative angle. So we know that we're going to go around, and we know that typically it's in quadrant 2, but since we're going downward, we're going to be in quadrant 3. So that will be your angle. For 2 pi over 3, we know that we're in 0 or 2 pi. We have pi over 2, pi, or 3 pi over 2. And so since we want pi over 3, we know that that's going to be in quadrant 2. So that will be your angle. For negative pi over 4, we know that typically it is in quadrant 3, but since we're going to go down, we're going to lie in quadrant 2. So our angle will be somewhere up here. So next we're going to look at converting from radians to degrees. And if you remember, when we do this, we're going to be multiplying by 180 degrees over pi. So let's start with pi over 9. And so when we're given pi over 9, and we want to go to degrees, we can multiply by 180 degrees over pi. Our pi's will cancel. So we have 180 over 9. If we put that into our calculator or use mental math, you will get 20 degrees. If we look at 11 pi over 6, when we multiply by 180 degrees over pi, our units will cancel. And we are left with 11 times 180 degrees over 6. 11 times 6 will give you 1,980 over 6. And when you plug that into your calculator, you will get 330 degrees. So next, we're going to convert from degrees to radians. And if you remember, we're going to multiply by pi over 180 degrees. So since we're given in degrees, we can multiply by pi over 180 degrees. Our degrees will cancel, and we're left with 100 pi over 180. If we divide by something that they're both common with, if we divide by 20, we will find that we will get 5 pi over 9. Similarly, if we have 150 degrees, we can multiply by pi over 180 degrees. Our degrees will cancel, and we're left with 150 degrees, or 150 pi over 180. If we divide by 30, so next we're going to look at trying to find an angle within 0 and 360 degrees of a coterminal angle, and we want it to lie there. So we know that if we take our plane, we go 140 degrees, we're going to go so many times and we're going to run out, and it's going to stop at an angle. So it could stop at 30 degrees, and that would be our coterminal. So it could go around multiple times until it finally stops, and then that would be our reference. However, since we're wanting to be within this degrees, we don't want to have to draw it or look how many times it has to go around the unit circle until it finally stops. So with the coterminals, we can just pull out until we're in this range, and we can see that that's going to be our reference triangle, or our reference angle. So if we look at 140 degrees, I would say take your angle that you're given, so 140 degrees, divide it by 360, so you know how many times it goes into it. And when you divide it by 360, you get 3.88 repeating. So if we do 360 times 3, we get 1080. So if we do 1400 degrees, and we minus 360 times 3, because that's how many times it was able to go into, we get 1400 minus 1080. And we're within 0 to 360, so our answer is 320 degrees. So if we take our coordinate plane, or our unit circle, we know that if we're going to go around with 140 degrees so many times until we stop at a given spot, and that will be our angle. But with us be able to find this coterminal angle, we know that however many times we go, we're going to stop at the 320 degree mark. If we go around 3 times for 360 degrees, so we go around once, twice, and 3 times, we're going to stop right here at 320 degrees. And so that would be our coterminal angle, or our reference angle. So if we have a negative angle, we can similarly do it, but we want to just keep adding to it until we're within the mark of 0 and 360. So I would similarly take 1600 divided by 360, which will give you 4.4 repeating. We can multiply 360 times 4, we will get 1440. And so when we take negative 1600 plus 360 times 4, because that's how many times it was able to go into, we get negative 1600 plus 1440, and we will get negative 160 degrees. But we want it to be within the 0 and 360, so we can add another 360 degrees, and we will find that it equals 200 degrees. So next we want to be within 0 and 2 pi for a coterminal angle. So similarly, when we did the degrees, we can still do the same thing for pi. So we have to be within 0 and 2 pi. So with the angles that we're given, we're either going to go positive or negative. So if we go positive, we're going to go around so many times until we stop for that given angle, but then that will be our reference. So with doing it between 0 and 2 pi, we just want to find out where that angle is rather than going around so many times until it stops. So if we look at 10 pi over 3, I would say go 10 pi over 3 minus 2 pi over 1 from it. And so we know that when we multiply or add and subtract fractions, we want the same denominator. Our 2 pi over 1 by 3, we get 10 pi over 3 minus 6 pi over 3. If we subtract, we get a 4 pi over 3, and that is within our 0 and 2 pi. So if we have negative 44 pi over 9, we can add 2 pi over 1. Since we want the same denominator, we can multiply our 2 pi over 1 by 9. We get negative 44 pi over 9 plus 18 pi over 9. If we add it once, we get a negative 26 pi over 9. If we add it again, we will get a negative 8 pi over 9. And if we add it one more time, we are within our 0 and 2 pi. So our answer is 10 pi over 9. So now we're going to try to find the exact values for our trigonometric functions. So we know that our for sine pi over 3. We know that pi over 3 is 60 degrees. So now we're going to look at trying to find the exact values for trig functions. So first we're going to look at sine of pi over 3. So we know that pi over 3 is 60 degrees. So we will get this triangle. We know that from across from the 60 degrees we have a square root 3. Then our hypotenuse is 2 and our leg is 1. And we know that we're in quadrant 1, so everything is positive. Remember that sine of theta is equal to opposite over hypotenuse. If we look at our theta, we want opposite over hypotenuse, and we can get our exact value. So sine of pi over 3 is equal to square root 3 over 2. So in the next one, we can do a similar process, and we can have seen the last one where pi over 3 is 60 degrees, and we can get our special triangle out of it. And for cosine, we know that our cosine of theta is equal to adjacent over hypotenuse. And so since we want cosine of pi over 3, we know that if we do adjacent, we're going to have 1, and our hypotenuse is 2, so our answer is 1/2. So next, we can look at tangent of 5 pi over 6, and we can see that 5 pi over 6 is going to be in quadrant 2. So we'll have this kind of triangle. We'll have our theta here, and it will be 30 degrees. So across from the 30, we have a 1, 2, and square root 3. And since we're in the quadrant 2, we know that our x is negative, our y is positive, and our hypotenuse is always positive. So we know that tangent of theta is equal to opposite over adjacent. So if we're looking for tangent of 5 pi over 6, we know that if we look at opposite 1, adjacent negative square root 3. So if we rationalize our denominator, you could leave it as 1 over negative square root 3, or you could rationalize your denominator. If we do that, we can multiply it by square root 3, and we get a negative equals a negative square root 3 over 3. So next we can look at secant, and we know that pi over 4 is 45 degrees, and so we will have a 45, 45, 90 triangle, and we know that it's going to be 1, 1, square root 2. And since we know that secant of theta, hypotenuse over adjacent, or 1 over cosine of theta. So since when we're doing the exact values, it kind of works, because we're going to look at our hypotenuse of square root 2 and our adjacent of 1. So we know that our answer is just going to equal square root 2. So next, we're going to find the requested value. So if cosine of t is equal to 2 over 9, and t is in the first quadrant, what is sine of t? So if we draw our picture first, so we know we're in the first quadrant, so we don't really got to worry about any positive or negatives. So we know that cosine of t is equal to 2/9, but we want the sine of t is equal to what? So we know that cosine of theta is equal to adjacent over hypotenuse. So we know that sine of theta is equal to opposite over hypotenuse. So next we can draw our triangle. And so if we have our right triangle, and we're not sure what our lengths or sides are because we're just given t, we know that for our adjacent, so if we use this being our theta, if we know that our adjacent is 2, and our hypotenuse is 9, so we want x. So we can use the Pythagorean theorem for a or b and set it equal to 9 squared and find our value. So if we use our Pythagorean theorem, a squared plus b squared equaling c squared, we get 2 squared plus b squared equaling 9 squared. We get 4 plus b squared equaling 81. If we subtract a 4, we get b squared is equal to 77, and we will find that b is equal to the square root of 77. So our x is equal to the square root of 77. So since we want sine, we can do opposite square root of 77 over hypotenuse 9. So sine of t is equal to the square root of 77 over 9. So next we want to find the exact values, and typically I would recommend using your unit circle. So we're going to look at trying to find the x and the y values, and then we're going to basically multiply those together. So if you remember that sine of theta is equal to the y value, and cosine is equal of theta is equal to the x value, and we know that tangent of theta is equal to y over x. So if we have sine of 3 pi over 4, if we look at the unit circle, we can see that 3 pi over 4 is 135 degrees, and we know we want the y value, and so we will get square root 2 over 2. And for cosine of 5 pi over 3, if we look at our unit circle, we can see that 5 pi over 3 is 300 degrees, and since we want the x value, we will get 1/2. If we multiply straight across, we will get square root 2 over 4 as our answer. So if we look at cosine of negative pi over 3, if we look at our unit circle, we know that pi over 3 is going to be negative. So we're going to be at 300 degrees, and we want our x value, so we're going to get 1/2. And if we look at cosine of pi over 4, we know that we'll get pi over 4, and we want cosine being the x value, we will get square root 2 over 2. And our answer again will be square root 2 over 4. So next we're going to be given a triangle, and we want to find the missing sides and angles. So first I would list out what you need. So we want angle B, side C, and side B. So we know that since we are given 2 of the 3 angles, we know that a triangle is 180 degrees. So we can take 180 minus 90 minus 30 degrees, and we will get 60 degrees. So we know that we'll have a 30, 60, 90 triangle, but we aren't given those values because we have a 7 over here, and we still got to find B and C. So if we look at trying to find side C, we can use angle B, so being 60 degrees. So if we look at cosine of theta equaling adjacent over hypotenuse, we can take cosine of 60 degrees over 1 is equal to our adjacent 7 over a hypotenuse C. If we cross multiply, I would put C on the left is equal to 7 over cosine of 60. If you plug that into your calculator, you will get 14. Since we were able to find side C, so we know that it's 14 degrees, we can either use another trig function, or since it's a right triangle, we can use the Pythagorean theorem. And I'd personally rather use the Pythagorean theorem. So if we take a squared plus b squared equaling c squared, we know that we have a being 7, c being 14, and we're looking for b. So 7 squared plus b squared equaling 14 squared. 7 squared is 49, plus b squared equaling 14 squared is 196. If we subtract 49, we get b squared is equal to 147. If we try to get rid of the square and we do the square root, we get b is equal to the square root of 147, but we can simplify that. So we know that 49 times 3 is 147. So we do 49 times 3. We will get that b is equal to 7 square root 3. So next we're going to look at this application problem. So a 23-foot ladder leans against a building so that an angle between the ground and the ladder is 80 degrees. How high does the ladder reach the top of reach the side of the building? So we know that our ground is our leg. We know that we have our ladder. And so that our ladder will be the 23 feet. And we know that they say that our angle is 80 degrees. And I would understand that it would be a 90-degree triangle. I don't think it would be a non-right triangle. So I would assume it's a 90-degree triangle. And if we look at trying to find the missing angle, we will get 10 degrees. And so we're left to find x. And so we want our other leg. So if we look at using the sine function, or the sine trig function, we know that sine of theta is equal to opposite over adjacent. So if we look at using our trig functions, we know that sine is equal to theta So we know that if we're going to use our 80 degrees as our angle, or our theta, we know that for sine, we want sine of theta is equal to opposite over hypotenuse. So if we want sine of 80 degrees is equal to opposite being x over our hypotenuse being 23. So if we cross multiply, we will get x is equal to the sine of 80 times 23. And when you plug that into your calculator, you will get that x is equal to 22.65057, and you could round that to 22.65 feet.